All right, are y'all ready to talk about the layers of the earth? I think I already told you, but this is one of my favorite units. I just love, love, love the science of earth. So let's talk about these layers. So, the Earth's interior. Most scientists agree that soon after Earth's formation, Earth was a large ball of molten or melted rock. As time passed, the molten materials cooled, hardened, and then separated out into layers. So those layers separated out because of density. And we've talked about density before. We just talked about density in the last unit whenever we were talking about those convection currents. Things, the less dense they are, the higher they're going to go. The more dense they are, the more they're going to sink. So that is why we have these different layers in Earth. So on top, the least dense layer is Earth's crust. The next, we've got the mantle, and the mantle is molten rock. And then the most dense part of Earth's layers is the core. And the closer you get to the middle of Earth, to the center of Earth, I should say, the more dense things are becoming. All right, so the part that we live on, we walk around on, we enjoy life on, is called the crust. So the crust is a thin outer layer that covers the whole planet. It's not very thick compared to the rest of Earth. It's only 8 to 32 kilometers thick. Now, I don't know if you can kind of wrap your head around a kilometer, but whenever you're talking about how big the Earth is massive, right? 32 kilometers really is just not that much. I mean, it's just not. And our crust is kind of cool because there's two different types of crust. We've got oceanic crust, and it's really pretty dense. And that oceanic crust, I wonder if you can guess where on Earth that goes. Under the ocean. It kind of gives it away, right? Oceanic crust goes under the ocean. It's very, very dense. It's made of basalt. And by very dense, I mean more dense than the continental crust, which is the other type of crust. Continental crust is what is sitting underneath your house right now. It's underneath school. That's the land. Continental crust, that's the stuff that we walk around on. The other kind is only found under the ocean. Next on our list is the mantle. So we've got the crust on top, and then we have the mantle. The mantle is the middle layer, and it's really, really thick. So whenever we think back to the crust, we said it's between 8 and 32 kilometers thick. Well, this mantle is 2,900 kilometers thick. So that's massive compared to the parts that we live on and walk around on. Kind of crazy, right? The mantle's made of silicon, oxygen, iron, and magnesium. And it's a solid that has plasticity. And what that means is plasticity is a solid that has the ability to flow. That's one of your vocab words, and we're going to get to play around with plasticity here in a little bit after, later on in this assignment. So I think you're going to enjoy that. The next layer we're going to talk about is the core. Now, the core of Earth is the central part of the planet. So we've got the crust, we've got the mantle, and then we've got the core, which is the inside. It's made of iron and nickel. It's about 1/3 of the Earth's mass. So the core, when you think about the whole Earth, you think about the core. 1/3 of Earth's mass is a lot. There's a lot of mass inside the core of Earth. It's really, really hot. The further inside Earth we get, the hotter things are getting. It kind of sounds a little bit backwards, but the closer to the middle you are in Earth, the hotter things are. Now there's two different parts to the core. We've got the inner core, which is the inside, and the outer core, which is the outside. The inner core is a solid. It's still made of iron and nickel, but it's a solid. The outer core is made of iron and nickel, but it's a liquid. So those are the differences between the inner and outer core. So here we got a picture of an egg. And I kind of like this analogy whenever we're talking about Earth's layers in an egg. Well, how are Earth's layers similar to an egg? The shell is kind of like the crust. It's really thin, but it's kind of hard and it's on the outside. The egg white, if you look in the picture, the egg white would be the mantle because it's right below the crust. It's in the middle. And then the yolk would be the core. So whenever you're thinking about the layers of Earth, you can think of an egg, and maybe that'll kind of help you visualize what we're talking about. So I've gotten some really good questions over the years talking about Earth's layers. And the best one, I think, well, one of the really good ones anyway. Do scientists travel inside the Earth to learn about the layers of the Earth? Well, the problem is that high temperatures and tremendous pressure in the Earth's interior makes traveling there and staying alive impossible. It's just not possible. It's too hot and there's too much pressure. We would never be able to survive. Even the deepest oil wells are only a few kilometers deep, and the diameter of Earth, so from the crust to the middle, is 12,756 kilometers. So, and if the oil wells, the very deepest holes we've ever dug in the crust of Earth are still just a few kilometers deep. Compare that to the whole diameter of Earth from the outside to the middle. It's not possible. It's not possible. So that question then stirs up this question, which is also a really good question. Well, if we can't go there to learn about it, how do we know about those layers of Earth? Well, we know because the study of behavior of seismic waves has allowed geologists to piece together the information about parts of Earth that man has never seen directly, like the different layers. And a seismic wave, let's talk about that for just a minute. We hear about seismic waves whenever we talk about earthquakes. And when earthquakes occur, vibrations are sent out through Earth. These vibrations are called seismic waves. So anytime you hear about an earthquake happening, there's seismic waves and they travel through the interior of Earth. There's different types of seismic waves and they're all really, really cool. But that's what they are, and that's how we know about these layers of Earth. So here's some more about seismic waves. I think they're awesome and fascinating. So seismic waves can travel along the surface of the Earth or through its interior. So there's different waves that do different things. The waves speed up, slow down, or completely stop, depending on the type of material that they're passing through. So for example, like all these different types of waves, an S wave, an S type of seismic wave, are waves that can't travel through a liquid. So as we're talking about the different layers of Earth, scientists know that the part of Earth that S waves can't go through, we automatically know it's got to be a liquid because they travel through every other type of solid. Kind of cool, right? So that's why we learned a lot about Earth's interior by looking at these seismic waves. Okay, so for our layers of the Earth, there's 5 layers that we are going to talk about. And you already know these words because we learned about them whenever we were doing our vocab yesterday. The first one's the lithosphere. That's the rigid outer layer. And remember, that's the crust and an itty bitty bit of the mantle. So the lithosphere is the one that we live on. It's the crust and a little bit of the mantle. Then we've got the asthenosphere, and the asthenosphere is rock that flows very slowly, kind of like hot asphalt. I don't know if you've ever seen that before, but when you think of the asthenosphere, think of solid rock that flows slowly, that has that plasticity that we were talking about. Next, we've got the mesosphere, which is the middle layer. Then the outer core, which is a liquid layer. And the inner core, which is a solid, very dense layer of Earth.